section 6.3. This is our last section for chapter 6. This is going to deal with our actual trends of the periodic table. Where do we find our information? How does it move through, left, right, up, down, and what we can use this information for. You've got trends of atomic radius, ionic radius, ionization energy, octet rule, and then electronegativity. So those are the topics we're going to cover in this little podcast. The first one's atomic radius. Atomic radius is the measure of how large an atom actually is. So you're going to take from the center of the atom all the way to the outside electron orbit. So however far it takes you to get out there. So it kind of makes sense that the smaller ones would be your smaller atoms, the less electrons you have, because there's not as many shells to reach out by distance. So what we have in atomic radius is your trend is going to go larger down the periodic table and is going to be bigger in your positive ones that want to become positive, so your cesium down by francium. So our goal is to try to get down by francium if we can, all right? What we've got is we've got two different charts here. One actually shows you the radius in a spherical manner. So we've got your lithium as you move down through the group. Lithium, there you go, lithium, sodium. Notice we're just keep getting bigger as we move down. So
and notice we're in the same group, group 1.
There we go, all
Cesium,
the way down.
And then francium will be below it.
Yep, and it'll be bigger, but there's francium so rare in the universe we barely even talk about it. Now, the other chart we have over here is also atomic radius, and it goes by group. Now, it does not go by group, it goes by row. So as you see, if you want to find lithium, there's lithium. So lithium is your group 1, and if you move to the next one, dot down, that's group 2. So we're moving down in radius as we actually move across a row. So we're going through the row, boom, 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 boom,
13, 14, 15.
16, yeah, 17, and
I
then 18. So there you have your fluorine. So you've moved from lithium all the way to fluorine, and it just shows you a numerical value of where your atomic number is going up, but the radius goes down as you move across the row. All right? So biggest thing, down.
Yes. It goes down your periodic table,
and
it also goes to the left-hand side.
That's going to be your big ones. All right? What you're going to have in your notes is we're going to actually compare some atoms. Mrs. Kelly, you want to grab the notes and we'll see, maybe we'll do one of them and then let you guys do a couple other ones. Which element is larger? We have K or O.
Okay. And you won't actually have this chart, so you may want to practice using your actual periodic table. But potassium is going to be in the first group, and it is in the 4th period or 4th energy level. Oxygen is over here, it's the 2nd energy level, and it's group 16. So if we know that the trend is that atomic radius increases as we go to the left and as we go down through the periods, we know that potassium is going to have a higher radius.
All right, so we would circle K on your notes. We'll leave you to the next two to try on your own. Double check your periodic table. Make sure you're looking at the ones that are farther over here. All right? Okay. Let's talk the next one. Ionic radius. So when something actually gains a charge, you could gain a positive charge if you lost an electron. You could gain a negative charge when you gain an electron. So what happens to your radius when you change? When you become positive, so if we look at lithium, lithium is on group 1. It's at the very top. Lithium has, if we draw its dot diagrams, Li, we're going to draw its shells. Sort of.
That's awful.
You know what? We'll live. You'll be all right. You'll get the idea. So the first shell has the two dots. Now the next shell for lithium has so lithium total has 3 electrons. We're going to draw all 3. First shell has 2. The next shell has 1.
Yes.
Now lithium wants to become positive, which means it wants to lose that electron.
Yes.
So if we lose that outside electron, what happens to that shell?
It goes away.
You've lost an entire shell, which means when you become positive, you're going to become smaller because you lost a shell.
So you lost your shell, so now lithium's going to look like that.
All right, become smaller.
Yes.
Now if we go to the other side of the periodic table, so if you're looking at your fluorine, if we want to draw fluorine, Fluorine has 9. Is this too many to draw?
Oh my gosh. All right, fluorine.
Let's just draw the outside one.
Let's do this.
So fluorine's
No
very...
way. We got it.
All right, 1, 2.
Uh-huh. Okay. 1, 2, 3, 4, 5, 6, and 7.
All right. So we've got our outside shell. Right now it has 7, but it wants to get to 8. We've been talking about this for a long time. Once it gets that other electron, it becomes negative. It's actually going to gain that electron, and those electrons, because they are like charges, is going to repel each other.
Yes.
Once they repel, everybody wants to expand away from each other. They don't like each other.
Yeah.
So you're adding in another negative to an already negative bunch. You want them to move away from each other, which means the negatives are going to get bigger.
Yeah, electrons want to be as far away from each other as possible, just like protons want to be as far away from the other protons.
All right. Ionization energy, your next trend we're going to talk about. Ionization energy is the energy needed to remove an electron, or how strong an electron wants to hold on to one. Now what we have to kind of think about, who wants to lose electrons? Your groups 1 and 2. They want to get rid of it. So it's not actually going to be a lot of energy for them to get rid of it and wants to hold on to it. Now your negative part of your chart, your fluorine, your chlorine, your bromine, they really want that negative electron really bad. So its ionization energy is going to be very, very high. So fluorine we're going to use as our highest trend for this one. And we're going to just compare, again, atom to atom, who's going to have more ionization energy. Again, your trend up to closer to fluorine has the most energy.
Right.
So you've got a problem on here. We're going to look at chromium and tungsten.
Okay.
Tungsten is, again, Mr. W towards the bottom, right there.
Oh gosh.
Okay.
There we go.
And then chromium is right above it in its same group. So which one of those is closer to fluorine?
I would have to say chromium.
All right, so chromium's going to have your higher ionization energy.
Yes.
And that's pretty much it. You're just going to look at who's closer to fluorine. Okay? Let's go to the next one.
Got it.
All right, your octet rule. Oh, we've been talking about this for a while. Atoms tend to gain and lose or share electrons to have a full outer shell. Just like we mentioned with fluorine. Fluorine wants to gain that 1 to get to 8. Octet rule, octet, 8, want to get to 8. That's a simple, very easy trend.
Very easy.
The very last one here, electronegativity or electron affinity. When you something has affinity, it's going to grab a hold of it or pull it in. So electronegativity is the ability of the atom to attract electrons in a chemical bond. Well, who wants to gain them? It's pretty much the same trend as ionization energy. Fluorine wants to gain.
Yes.
Your noble gases are pretty much out in this group because they don't really care. They're already stable. They don't need any more. They're fine. So we've got to look at our halogen group. That's our go-to group.
Right.
Fluorine's going to be our top one here. This is where we want to go. So in your notes, we have fluorine or lithium. Who's going to have the highest electronegativity? Well, we just said fluorine's the top one. Notice they're in the same row, though. So we're getting you to compare row within that same period, lithium compared to the fluorine. Fluorine's going to have the more electron affinity. It wants to gain it, or electronegativity wants to gain that electron. Let's summarize.
Okay.
All right.
So a lot of the trends that we talked about, we're going to go through and kind of label your periodic table. So I would suggest going back to the beginning of your notes where you labeled your alkaline earth metals, your halogens, and you colored in the S, P, D, and F blocks. Go back here and draw in arrows for your atomic radius, ionization energy, and electronegativity.
All right.
Okay, and memorize them. So this one, you've already got electronegativity. It increases as you go towards fluorine. So as you go to the right, where is my pointer? I don't know. Electronegativity increases as you go to the right. It also increases as you go up. The other one that increases as you go left and as you go up is your ionization energy.
IE.
Okay? The other one that we talked about is atomic radius. Remember, your highest atomic radius is going to be francium. It's pretty rare, so most of the time it's going to be cesium. But your atomic radius is going to increase, as you go meander your way over to francium. Okay? This is a R.
Atomic radius, biggest down into the bottom left. Everybody else is up into the top right.
Another thing, look on your cheat sheet. It is on your cheat sheet.
Yeah, find it.
It's easy enough to remember that you can do this. You're looking at fluorine, you're looking at francium, and you just have to memorize a couple things. But it is on your cheat sheet if you get stuck on your test.
All right, the very last part that we have is just a couple videos. These were made by students. It's a periodic trend to help you remember. And then there's an element song, which if you can memorize and actually sing to us, we would be so impressed.
Yes.
There might be quite a bit of extra credit. So far, Miss Kelly, in my 10 years of teaching, goose egg on people that
I don't
have
think I could
memorized
do it.
No, I couldn't either.
But
we've also had it sung by Daniel Radcliffe, the guy that did the whole
Harry Potter.
Harry Potter. He sings it too, so enjoy those. Make sure you watch a couple of those videos. They're really good. And we're done with chapter 6.
Yay!
Yeah.